Hello everyone and welcome to Processing. Today we'll introduce a few important functions that you'll need in order to begin coding the various screens of your project. Have document 15.1 in front of you and follow along. We'll start by opening Processing. Now we'll save it and we'll title it 15.1a since this is from document 15.1 and it's activity A, and then underscore your last name dot your first name. And for right now, we're just going to save it directly to the desktop. The first thing you should always do when writing a new program is to create a header. Now your header is not actual code that's going to be run by processing. It's just text that's going to be read by a user or someone else who's reviewing your code. So we write these two slashes to indicate that it is a comment, and again, processing won't run that code. And we're going to include a few things: title, author, when it was started, and the date last updated. I went ahead and typed in all that header information. The last bit of the header is just simply a description of what this sketch does. And for that, it could be multiple lines. So rather than write this / before each line, there's something else I can use, which is a slash and then an asterisk. And I can hit enter there and I can start writing what this is. So a description, and specifically this sketch includes and then I want to close that comment by doing just the opposite. And notice the little errors and the squigglies, they all went away because now processing recognizes this. Now I'm ready to begin coding. Specifically, the first thing we'll do is generate some shapes. We'll start with drawing a rectangle at various locations and with various dimensions. So at this point, please refer to your handout. Follow the instructions in questions 1 through 4 in activity A and answer the questions on the handout. Pause the video here, and when you're finished with activity A, restart the video. All right, welcome back. Through this activity, you should have learned a few things. I'm going to go to the processing website for a moment, which is a great resource that any of you can use, processing.org. But we learned there's 4 arguments with our most basic rectangle, and that is the x-coordinate of the starting position of the rectangle, the y-coordinate of the starting position of the rectangle, and then the rectangle's width and the rectangle's height. We also learned that the starting point of a rectangle is the upper left corner of that rectangle. We also learned that the default canvas size in processing is 100 by 100, which means 100 pixels by 100 pixels large. That's how big the canvas is. Lastly, we learned that the origin, or 0, 0 of the canvas is also defined as the upper left of the canvas. Now let's move on to activity B. You should have saved your previous sketch as 15.1a, last name, first name. We're going to do the same thing. Per the directions on the handout, we're going to open a new sketch. So an easy way to do that is just hit Control N, and it opens a new sketch. And we're going to do the same thing. We're going to save as. I'll do that offline, then come back. Follow along on the handout, answering the questions for this activity. Pause the video here, and when you're finished with activity B, restart it. Through this activity, you should have learned that you can easily resize the canvas in processing by using the size function. Go ahead and save your file, and let's move on to activity C. Just like with activity B, open a new sketch and name it appropriately and include your header. In this activity, we'll play around with some of the other shape functions that exist in processing. Go ahead through numbers 1 through 3 in activity C. Pause the video here, and when finished with activity C, restart it. For this activity, you should have learned about the function for creating an ellipse, and I'll reference the processing.org website again. Notice there's 4 arguments in an ellipse, where A and B are the x and y coordinates of the center of that ellipse, and C and D are the width and height of the ellipse. For a triangle, we use the triangle function, but you'll note there's 6 arguments in the triangle function. Here, they're paired, where x1 and y1 are the x and y coordinate of one point of the triangle, one corner, one vertex. x2, y2 is a second point, and x3, y3 is a third point. line is very similar to that in that you're indicating the x and y position of one point, the x and y position of another point, and then connecting those. The line function connects those 2 points with a line. You've saved your sketch for activity C. Now you can open a new sketch, calling it activity D. Be sure to include your header. As stated in the handout, you might wish to store a value and use it throughout your code. We call this a variable. This activity D is all about storing and retrieving those variables. Go ahead through the activity, pausing the video here before proceeding. Hopefully, that activity went well. For question number 3, you should have discovered that the arguments needed to make the rectangle as specified are 0, 0, rect width, and rect height. For question 5, you should have discovered that the arguments needed to make the ellipse as specified are width divided by 2, height divided by 2, 50, and 50. Go ahead and save this sketch one last time before moving on to activity E. Now, just like with all the previous activities, we're going to open a new sketch, save it with the appropriate file name, and include the full header. Now, up until this point, we've been using Processing's default background color for the canvas, gray. To set the background to black, we can use the background function. At this point, create a 50 by 50 rectangle at coordinates 25 and 25 on a canvas that's 200 by 200 pixels. Take a moment to write those lines and to write the background function into your sketch in the line just before the rectangle function. So here's the background function. Go ahead and do that now. Now here's what your code should look like. And if you run it, you'll see a white rectangle on a black background. Now go ahead and see what happens when you move the background function, meaning line 12 right here, when you move that function after the rectangle function. Run the program to see the desired outcome and respond to question 1B on your paper. Pause the video for a moment while you do this and restart it when you're finished with 1B. Now play around with changing the argument within your background function using any value in the range from 0 to 255. What do you notice? Write your answer under question 1C and 1D on the handout. Pause the video here, try this out, answer the question, and restart the video when you're finished with both 1C and 1D. What you should have noticed is that a background function with a single argument will return a color in grayscale, and that 255 is white. Now, let's try passing 3 arguments to the background function, each one from 0 to 255. Change the arguments in your background function to the following: 200, 255, 50, and you'll notice I moved the background function back above my rectangle. When you play it, you'll notice that background is a totally different color. So take a minute to play around with each value individually, meaning each of these 3 values individually, to try to figure out what each argument could represent, meaning what does this first argument represent versus this versus this. Then write what you think each one is in the space below on your paper. Pause the video here to play around with changing the 3 arguments, respond to 2B on your handout, and then restart the video. What you should have noticed is that each of the arguments indicates the amount of each color, red, green, and blue, respectively, that they are in the color blend. There will be many times that you know what color you would like something to be, but won't be able to easily determine how much red, green, and blue is in it. For this purpose, Processing has a custom color selector tool. Go to Tools, then Color Selector, and then use the Copy button to copy the code and paste it into your background function. Follow along here to complete the step. In Processing, all shapes have an outline, or a stroke, and a fill. Each of those components have a related function. If you don't specify the stroke and fill, Processing defaults to using a black outline and a white fill. Suppose we don't want a white rectangle. We can use the fill function to change the color of a shape. So here I've gone to the Tools color selector. I found a color that I liked. I copied it and I pasted it here, and I wrote that line of code, that fill function, right above my rectangle. And when I play that, you'll see my nice light blue square in my canvas. At this point, I should change my comment because I'm doing more than just setting the background color, but I'm setting background, stroke, and fill color. So next, if I want to change the outline, which is what this stroke refers to, I can use this stroke function. So I'm going to do that just like I did with the fill before the rectangle. So I can write stroke. I'll use the color selector tool, find some color that I like, copy that, paste it, and now I have some nice outline color here, that reddish color that I picked. But you know what? That is a little bit thin, so if I want to change the weight or the thickness of that stroke, I could do stroke weight, which is a different function. So let's play around with that. So here, I can type in stroke weight, and let's pick 5 and see how that looks. Oh, you can see it's much thicker now. If I want to get rid of the outline altogether, I can replace both the stroke and stroke weight with a different function, no stroke. And here you'll see that I have no outline. Let's go back because similarly, rather than fill, I can use a no fill function, which then gets rid of the fill color, but I've kept my stroke back in there. And there you can see that. Pause the video when you're finished coding these lines to answer questions 4A through F on your handout. Lastly, we'll learn about how processing can randomize a color for you. We can use the word random, which is a function, for one of the color arguments to our background. So if I look at my background line and I type in random, and now the arguments here is going to be a range of 0 to 255, and that's the R value of my background color. Let's change this to something like 50, 30, and let's play it, and hopefully we'll get some random options here. Here it's like a brownish version, a little darker brown. It's a little bit green there. So you can see I'm randomizing that particular argument within my background function. Take a minute or two to mess around with randomizing various colors in your sketch. The color should be different each time you run the sketch. When you're done, save this sketch for activity E, and then we're going to open a new sketch for activity F. So here's my sketch for activity F. Now, we've practiced drawing lots of shapes, but those shapes have been static or motionless. Given that our games involve motion, let's demonstrate that by having a shape follow the mouse. The way processing will handle this is by redrawing your specified shape over and over again at a location dictated by your mouse. So first, let's initialize the variables for the size of the rectangle, and I'll set those to something relatively small, like 50. Next, let's set the canvas size to 600 pixels by 600 pixels. Now I'll use the rect function to draw a rectangle, and rather than specifying specific pixels for the origin, I'll specify mouse X and mouse Y. Let's give it a try. So let's run this. Now you'll notice it doesn't work. And here's why. I want the canvas to be set up one time, but I want the computer to be continually looking at my mouse's position and drawing a new rectangle. For that, we're going to use some built-in functions called setup and draw. The setup will set up the canvas size once, where draw will happen over and over again, which is called a loop. The convention is that we write the word void in front of those functions because they don't return something, they just do something. Unlike, for example, the rect function, which creates a rectangle on our canvas. Everything I want in that function will be contained by curly braces. So now we'll add those in and see what happens. And now I'm out of time, so we'll go ahead to the second part of this video tutorial.